Okay, it's given that a body strikes a stationary body of mass capital M. So there are two bodies, and they undergoes an elastic collision. After elastic collision, M, that is the first body, has a speed one third of its initial speed. What is the ratio of their masses? So let's say this is the first body and this is the second body, and the mass of the first body is M. Mass of the second body is M. So mass of the second body is M, and once and initial velocity of the let U1 be the initial velocity of the first body, and second body is at rest, so its initial velocity is 0. Let V1 with the final velocity of the first body after collision, and it's given that it is a one third of its initial speed. So initial speed is U1, so it is one third of the initial speed, and V2 is not known. So V2 with the final speed of the second body. So we are going to make the equations in this case, and first of all we are going to use the law of conservation of momentum. So according to law of conservation of momentum, initial momentum is equal to final momentum. So this is initial momentum is equal to final momentum, and we know that initial momentum is given by m1 u1 plus m2 u2 and m1 v1 plus m2 v2. M1 is M, U1 is not known, M2 into U2 is 0, so M2 is M, mass of the second body is capital M, M1 is M. So initial final velocity of the second body is one third of the initial body, M2 is M, V2 is not known. Okay, M into 0 is 0, so this is M into U1 is equal to, this is M U1 by 3 plus M into V2. So let's try to simplify this, and now MV2 is equal to MU1 minus MU1 by 3. So which gives me, this is 2M U1 by 3. Okay, if we shift this to the left hand side, this is MU1 minus MU1 by 3, which is 2M by 3 U1. Okay, and we have to find the ratio of the two masses, so let this be equation 1. Okay, and now it's given that it's an elastic collision and we know that for elastic collision, coefficient of restitution is equal to 1. So E is equal to 1, and coefficient of restitution is the velocity of separation, which is V2 minus V1 upon velocity of approach, which is U1 minus equal to 1. Okay, V2 is not known and V1 is one third of the original velocity. U1 is U1 and U2 is 0. So this is now minus 1 by third of U1 is equal to U1, which gives me V2 is equal to 1 plus 1 by 3 V1, which is 4 U1 by 3. Okay, finally we have U2 is equal to 4 into U1 by 3. Let's get the value of U1 from this equation. So from first equation, we can get U1. So shift this to left hand side. So U1 is equal to 3 by 2 M into V2. So 3 by 2 MV2 by M is the value of U1. So let this be 1. And we are going to replace this value here. So this is equal to 4 into U1, which is 3. 4 by 3 into U1 is 3 by 2. So this is 3 by 2 MV2 MV2 by M. Okay, so 3 and 3 gets cancelled. This is 2, and V2 we can strike this off. So finally we have 1 is equal to 2 m by m, and m by m, the ratio of the mass of the second body to the first body is now 1 by 2, which is equal to 1 is to 2. So the required ratio is 1 is to 2.